Okay, in this next example, we're going to explore the effects of changing dimensions. Okay, so recall when we changed dimensions of a two-dimensional figure, and we did it proportionally. Say we doubled the dimensions. We decided that the area increased by 2 squared, or it increased by 4. Okay, now we're going to see a certain phenomena with volume when we discuss three-dimensional figures. Okay, now in this example, it's saying that the length, the width, and the height of this prism are doubled, and then we describe the effect on the volume. Okay, well, first of all, let's look at our original three-dimensional figure. So I'll call this original, okay, or call it old and new, or whatever you want. Okay, but I'm going to assume that these are right angles here. Okay, so I'm going to assume this is a rectangular prism. Okay, so at this point, I'm just going to say that my volume is going to be equal to the area of the base times the height, or we could just use volume equals the length times the width times the height. Okay, but either way, we get 4 times 3 times 1.5. Okay, and I'm just going to go ahead and quickly plug this into a calculator. 4 times, I know I could do this in my head, but I just don't feel like it right now. 4 times 3 times 1.5 is going to give us 18, right? So our volume is going to be equal to 18 cubic feet, okay, in this oblique rectangular prism. Okay, now let's look at our new figure. Okay, well, our new figure, if we double the height, the length, and the width, this is going to be 3. Okay, this is going to be 8, and this is going to be 6. Right, so our new volume is going to be equal to 8 times 6 times 3, which is going to give us, let's see, this is going to give us 8 times 6 times 3 will give us 144. So our volume is going to be equal to 144 cubic feet. Okay, and so now at this point, what we're going to be dealing with is figuring out, okay, now what actually happened to the volume, right? Remember this fraction that we can use to kind of cheat? We can do new divided by old, okay, and we can figure out, okay, what happened here? Well, our new volume was 144, our old volume was 18, okay, and so if we use our calculator and divide here, we end up getting 8. Okay, so I would say something like this. I'd say when the dimensions were doubled, the volume increased by, I'm going to call this 2 cubed, or 8. Okay, so this time we see that instead of it increasing by 2 squared when we're in 2 dimensions, it's going to increase by 2 cubed when we're in 3 dimensions. Okay, now this will also work the same way for cylinders. Okay, so if I look back on this one, I'm just going to go back to a previous example that I chose not to go through. Okay, if the radius and the height of the cylinder are multiplied by 2/3, the volume would be affected by 8 over 27. Okay, and so again, we just kind of have to see this particular relationship when we're working with either 3-dimensional figures or 2-dimensional figures.